My name is Dora. As you might know, I am not the coach of the MSG team. I'm the project leader. Our coach is sick at home watching the live stream right now. Hi. So we're very proud of our application. This is our team. And I clicked once too much. And this happens if you're not part of the dry run. So this is our team. I'm the project lead, Corinne is our coach, and we have our developers here, Christian, Oliver, Sabrina, Yanis, Anne-Christine, Marcus, Dominic. Our customer is also called Oliver, very conveniently, so you don't have to memorize too many names. And we created the application DIPS, and I'm going to hand over to Anne-Christine, who is going to tell you all about it. Thank you.
Okay, thanks, Dora, for the introduction. But now let's have a look behind DIPS magic. So imagine Tom. Tom lives in Ismaning and has a regular schedule. He gets up at 7, goes to work at 8, plays tennis after work, and enjoys a beer with friends at 8 p.m. Tom uses his car to get to work in Munich City. So every day he occupies another parking space near his office. Like dozens of others, Kate is looking for a parking space in the afternoon in Munich City. I think we all can imagine this situation. However, DIPS comes to rescue Kate. Over the past, DIPS learned Tom's regular schedule, and now DIPS can predict when he will leave his parking space. Kate uses this information, and when Tom finally leaves work, she can take his parking space. Of course, this sounds awesome so far, but let's see this in action. Janis is currently waiting to show us our application. Hey Janis, are you there? Can you show the audience how DIPS actually works? And by the way, did you buy the beer for the presentation, for the after party tonight?
Hi, Anne-Christine. Oh no, I actually forgot about the beer, but that's not a problem. I was going to show you how to find a parking space in DIPS anyway. So of course we have a super cool integration with Siri in iOS 12 beta. So let's see if that works. Hey Siri, find the next parking space. Now in the background, we're determining the best parking space. Our algorithm not only takes into account which is actually the closest parking space by distance, but also takes into account the time you would have to wait at the parking space until it frees up. And as well, the walking time it takes to get back to your current location. Oh, super cool, DIPS. We have a parking space opening up in 1 minute. So let's just drive there and wait until it opens up. Cool, I can enter the parking space. Okay, now let's get some beer. Oh, nice, some Augustiner. I guess that's not gonna fit. So, sorry team, just 2 bottles today. Let's see. Thanks, DIPS, for rescuing our after party. Back to you, Ollie.
Thank you, Janis, for this great demo. And you have just seen that DIPS predicted that a parking space will be free in the future. Now, DIPS is doing this with the help of machine learning. And naturally, for machine learning, you need a lot of data. So remember Tom from the beginning. As every DIPS user, Tom owns an iPhone. And with the help of his iPhone, DIPS is able to continuously analyze his location and movement. So DIPS might observe that Tom is at home sleeping in the morning. We can combine these into a measurement and annotate it with the current time. Now we can do this throughout the day. We might observe that he's at the office working at his desk, and we obtain another measurement. In the afternoon, Tom is usually playing tennis with his colleagues, so we observe that he's moving around and he's at the tennis court. Now, at the end of the day, Tom always enters his car and leaves his parking space. And that is the point where DIPS actually becomes smarter.
Well, Oliver, how is DIPS able to do that?
Well, firstly, we remember the time at which you left your parking space. And for all the data points that we collected in the past, we calculate the duration until you will leave your parking space in the future. Now, the combination of these measurements and the time until you will leave your parking space gives us plenty of data samples. And these data, we have a lot of these data samples as we track your location and movement every minute.
Wow, that sounds like a lot of data. So I kind of understand what you're saying, but see, every second Friday I get later to work and work longer hours. Is DIPS still able to predict correctly when I'm leaving my parking space?
Well, that is a great question indeed, and I'm proud to tell you that DIPS is actually able to do that, because what we're doing is we combine each data sample with data samples that we collected in the past, and we link them together into a sequence. Now, this sequence sort of models your behavior, and this behavior is linked to a time at which you will leave your parking space. We do this for all our data, and DIPS is finally able to predict when you will leave your parking space, not only based on where you are at what time and how you're moving, but actually on your behavior.
Oh, sounds pretty great. But can you maybe explain it in a little bit more detail how DIPS is actually able to foresee the future?
Yes, of course. Let's do an example. Say you're at home at 7:45 walking around, and half an hour earlier you were at home drinking coffee. DIPS doesn't actually realize that you're drinking coffee, but it knows that you're sitting at home, so this might be an assumption. And a few hours earlier, you were obviously sleeping in your bed. Now, exactly the same way we did it before, we can combine these measurements into a sequence. The only thing that is missing is the time at which you will leave your parking space. Now, DIPS is using a so-called random forest classifier, which consists of many decision trees. These trees draw conclusions from your current behavior based on what you have done in the past. And it predicts a time span in which you will leave your parking space. For example, 0 to 15 minutes or 15 to 30 minutes. Let's say it predicts that you will leave your parking space in 0 to 15 minutes.
Wait a moment, but it doesn't sound so great. I actually don't want to wait like 10 to 15 minutes to get a parking spot when I'm right there.
Of course, you're right. And that is why we have yet another random forest, this time a so-called random forest regressor. It is a smaller random forest and specifically optimized to accurately predict the time at which you will leave your parking space in that time span from 0 to 15 minutes. And it might predict that you will leave your parking space in about 5 minutes.
Wow, sounds great in theory, but did you actually get it working in practice as well?
Well, it was a bit tricky at the beginning because we didn't have any data. But with the help of our team members, we were able to collect data over a period of about 1,000 hours, and we collected over 250,000 data points. In the end, we were able to achieve an accuracy of about 90 seconds. That means when we make a prediction, in the worst case, it's 90 seconds earlier or 90 seconds later that the parking space is actually left.
Oh, thanks very much, Oliver, for the explanation. I actually have to leave now to get to the airport, and I'm going to use DIPS for that. So actually I have to remember where I parked my car. So let's maybe try this button. Oh, here. The parked car is just around the corner. I know what it is. So now I need to find a parking space at arrival time at the airport. So yeah, that looks great. You see, like I need like 90 minutes of travel time, and there's an estimated parking spot available in 22 minutes. So I just take this one and click here, and I can directly navigate over there. That's great. So see you guys.
Okay, to summarize what we did the last month, we showed that it's able to learn people's regular schedule and to make prediction about their parking behavior. We built a server architecture that can handle thousands of requests coming in simultaneously. And we added a destination search that shows you the best parking space at your destination given the travel time. We integrated Siri for a better user experience. And finally, we were able to show the user where he parked his car. But there's one more thing. We do not only bring you to your car, we want to bring your car to you. I think you might know our beta tester.
Wo ist denn jetzt mein Auto?
5 minutes later.
Ah, da muss ich nochmal Tipps fragen. Mal sehen, ob ich es dann finde. Oh Mensch. Halt, da war doch ein Geräusch. Ah, da bist du ja. Tipps funktionieren. Nicht, stopp, stehen bleiben, halt.
So thanks for the attention, thanks to my team, thanks to Oliver. Do you have any questions?
No questions at the moment. First of all, thank you so much for the last 3 months. I'm actually kind of sad because the time is coming to an end, and I was always really looking forward to seeing you at the end of a stressful day, especially like today. So guys, thank you so much. It's really, really great what you accomplished here within these 3 months. If all the teams in the world would perform this way, we would have so many great software out there. But really, be really proud what you did here. Really, really thank you so much.
Thank you.